Okay, so welcome to the fifth session. In the fifth session, we will look into neural network. Okay, so the discipline of artificial neural network arose from the thought of trying to imitate human being intelligence. So, but what they can do is they can program the machine in such a way that it can learn some kind of intelligence that mimicking human intelligence. For example, computer vision, natural language processing, and this they try to simulate what we have in our brain, what kind of input that we get, and then how do we process them, and then how do we produce the output. So if you look at the diagram here, deep learning is a general concept that we are trying to discuss here, in which artificial neural network is one of the a basic foundation of deep learning. So machine learning is a branch of AI. So all of you have taken artificial intelligence, and machine learning is a program or algorithm that is considered as one of the concept discussed in AI. And when we talk about deep learning, we have to start with artificial neural network because this is the foundation of deep learning. So the more complex your neural network and the deeper they are, then they are called deep learning concept. So ANN are example of machine learning algorithm. So when we say deep learning, basically we say deep learning is a complex set of neural network. So we have a set of neural network with more layer. If you look at the diagram below, we have the input layer, and then we have the output layer. So this is the data that we get, and then we try to model them based on the task that given to us, whether we are doing regression or classification or other things. Okay, so typical use for complex tasks such as image recognition, classification, and handwriting identification. Um, Neural network are inspired by the way the human brain works. So if you look at the diagram here, um, this is how neural network is set up, in which we have a few input, x0, x1, and x2. So this is our input. So when we try to map to the brain, it's called dendrites. So dendrites is the one who will receive all the input from our sensor. Okay, and then of course, when we try to model this x0, x1, x2 based on the um, task given here, so the task could be we could do regression or classification, okay, or recognition. So we have to estimate the weight here, weight 0, weight 1, and weight 2. So in order for us to fire the output, and the output will be given to the next layer. So over here, when we map to the um, biological framework here, the axon here is the one that will carry the output, and the nucleus here contain all the neuron that similar to here. So this is considered as one neuron here. Okay, so the nucleus is a set of neuron that will get all the input from the dendrites, and then it will fire the signal, electrical signal, to the next one. Okay, so a human brain can process huge amount of information at the same time using data sent by human senses. So we get from our hand, from our um, six senses that we have, five or six. Okay, some people have six. The processing is done by neuron. So this is considered as neuron, and nucleus is consists of set of neurons which work on electrical signal passing through them and applying flip-flop logic. So I believe you have learned this one. This is so the output will be trigger, will be fire if there is enough value here that can open the gate. So we will discuss later on. This is what we call activation function. Okay. So this slide define what are the terms that we are using, like the dendrites here. This is the entry point in which in each neuron which take input from other neuron. So we receive input um, using the dendrite. We also have axon. The axon is the one who carry the signal, and then we have nucleus. Nucleus is inside here. So this is a cluster of neuron, a set of neurons. And then we also have soma. This one, it generates inference from the dendrite input and decide what action to take. So this is considered as your activation function. Okay. So the action terminal, they transmit output in form of electrical impulse to next neuron. Okay. So this one is used to fire to the next dendrites. Okay. So based on this analogy, they try to map to the neural network concept. Okay, so for the neural network concept, they define the neuron as CPU, which perform some calculation and generate one output from a set of input. Okay, so they produce the output based on the activation function that they have. So we have a few type of activation function. Um, activation function will trigger the output if the total amount of signal received exceed some activation threshold. So it depends on what type of activation function you use. Your output will be different. Okay. So the output of a neuron is a function of weighted sum of impulse of inputs plus the bias. So basically summation of input, so from 1 to n, and then let's suppose your input is up to n, and then each input will have weight lah, okay, plus the bias. So this is your your output. Okay, so we could have a few layer, hidden layer. So the input layer will be the first one, and then we also have the hidden layer. So we may have a few hidden layer here, and we have the output layer here. So in order to understand the hidden layer, we have to know the weight, the bias, and activation function. What are they? Okay. How they works, and then how they contribute to the concept of artificial neural network. Okay, okay, for a typical neuron, if we have three input, x1, x2, and x3, then the synaptic weight to be applied to them are denoted as W1, W2, and W3. And basically, this is your output lah. Okay, so the Y here will be your output lah. Okay, so given a data set consists of three input and one one output, we try to estimate the weight for W1, W2, and W3. Okay, so the process of learning is called we call one way here feed forward, and then if you want to adjust the weight, we could also pass back the information back here. This is what we call back propagation. Okay? So the formula that we have here is the formula used by the neuron. Okay, so once we go one direction here, and this is what we call one epoch, one iteration or one pass through the process of providing the network with input and updating the network weight. So this is one what we call epoch. How many rounds you want to perform here? So it is a full run of feed forward and back propagation for update of weights. So basically, if you have feed forward, so this is feed forward, and then if you go back to update the weight, so this is back propagation. So this is considered as one epoch, okay, one round. Okay, so initially we will randomly initialize the weight by picking random number. Okay, so based on the output that we have here, it will modify the weight so that we can classify or we can perform classification accurately or increase the accuracy. Okay, so a training neural network is an act of presenting the network with some sample data, so your sample data here, and then modifying the weight to better approximate the desired function. So basically, given the input here, you will have to modify your weight here in order to better approximate the desired function. So what you want to do is you want to estimate W1, W2, and W3 so that whatever value that we have here, we can approximate the desired function. So the desired function will be this one. Okay. Okay. So like I mentioned just now, when let me clean this one first. Okay. Before you can fire this one, there must be some activation threshold here. So the activation function that we use, we have a few types here. So the first one is called linear function. So the linear function is a straight line. So the abstraction of the processing of neural network is mainly achieved through activation function. Okay. So for this one, the value of y will be the same as x. So whatever function or whatever value you have for the input, you will have the same for the y. Okay. We also have this unit step activation function in which when your value of x is greater than 0, then you will get activation function as 1. So they will only fire when your x equal to, no, greater or equal to 1. Okay, greater or equal to, no, greater or equal to 0. Okay, so this is the activation function for unit step. We also have this sigmoid, um, in which the value is within 0 to 1 only. So you still remember that we have this logistic regression in which we force the output to be between 0 to 1. Okay, so in neural network, we use this one also. So this squashes the input to any value between 0 to 1. So that means if you have a range of input value, they will be mapped to 0 and 1 only. Okay. Due to the fact that they have this pattern, they have gradient um, vanishing problem in which a large change in the input of the sigmoid function will cause a small change in the output because we are limiting them to 0 and 1 only. Okay, so hence the derivative becomes small. So the changes of the weight will become very, very small. Okay, so when the changes is very small, then the convergence process will be very slow because you cannot reach at the optimum value or condition in a faster way. Okay, and notice that also they are not zero center. Okay, um, this is commonly used because they are the the all activation function in which they are used long time ago. But there are few activation function like uh, hyperbolic tangent. So hyperbolic tangent is within the range of -1 to 1. And the gradient is stronger in which the derivative of the tangent are larger than the derivative of sigmoid. So in which you can reach the conversion status faster. Okay, and they are centered at the 0. So in most of the discussions say that the hyperbolic tangent is stronger compared to the sigmoid because tangent um, activation function is centered around the 0 and easier to um, get the convergence status. Um, Due to the fact that the other two may have vanishing gradient problem, they introduced the rectified linear unit. So this is in short called ReLU. So the range is between 0 to infinity. Okay. So this is simple and very fast. So most of them use this one. Your value x will be positive when your x is equal or greater than 0. Okay. So when you perform the practical later on, you will notice that you have many options, whether you want to use ReLU or hyperbolic tangent and sigmoid. And you can also compare the accuracy. So which one is best lah? Okay. Okay. To start with a specific type of neural network, we start with perceptron. Perceptron and multi-layer architecture. In perceptron, we only have a single neuron. Okay, that classify a set of input into one or two category. So usually one or minus one. Okay? And the perceptron usually uses a step function. So a step function is like this. So the value of your input, you, this one will be triggered when um, if the weighted sum of the input exceed a threshold of 0, okay, and 0 otherwise. So we also have the forward and back propagation. So the processing from each input layer, so this is your input layer, to your hidden layer. This is your hidden layer. And then this is your output layer. So when we go this way, this is what we call feed forward of information, forward propagation. Okay, so the for each of the layer, we will use the um, sum of the product of input and the weight plus bias for each of the layer, and then the activation function value is propagated to the next layer. Okay, so the more deeper or the more layer you add here, then they are called deep neural network because they have large number of hidden layer. So this one we try to differentiate between feed forward and feedback network. Feed forward means you only go one direction. Feedback means you get a feedback from your final output and then feed back into your hidden layer. Okay. Um, we also have recurrent neural network in which the output of the neuron is feedback into the neuron itself. So this is what we call recurrent neural network. Um, so in RNN, they propagate data forward here and backward. So two ways. Okay. So this is forward neural network because one way only. Okay. What happened? What happened if you get the output here? Okay. You get the output here, and then you compare the target output and your output, and then you compare. So any error or residual that you get from here will be computed, and then you will adjust the weight of your neural network here. So this is the process of learning where you get the input and then you get the output, you compute the error, then you feed back into your neural network, and then you adjust the weight. Okay? So the error is computed and used to correct the weight and the bias, and the amount of weight that must be changed is determined by gradient descent. So how steeply the error will be reduced or increased. Okay, how much weight that you want to reduce or how much weight you want to increase. Okay, so the back propagation keep changing the weight until there is greatest reduction in error by an amount known as the learning rate. So used to set the rate of adjustment to reduce the error faster. Okay, so if you look at here, if you have a good learning rate, as the number of epoch increase, you reduce the loss. You minimize the loss function, meaning you minimize the error. Okay, a good learning rate will have this curve. Um, High learning rate will produce this type of graph in which your loss function will be stagnant. Okay, low learning rate, you can reduce the loss function, but um, it require more epoch value. Okay, a very high learning rate, in which you get your uh, loss function reduce and then increase again, in which you pass the optimum value already, and you go far away from the optimum loss value. So we do not want this one. So that's why in neural network we have to try a few options on what is the best value of your learning rate. So these are the parameters that you need to look into when you want to train your neural network. The learning rate, and also the epoch number. Okay, so when we talk about the gradient descent, we are looking at a concept in which an iterative approach for error correction. We want to reduce uh, the error. Okay, so what happened is, if the initial weight is here, so if your global cost is minimum at here, we want to move your weight from this position to here. Okay, but how fast, it depends on your learning rate. Okay, how much you want to change the weight. Okay, if you go very fast, then you will go up here again. So that's why you take a baby step, small step, until you find the best one. Okay, so if you increase them too much, then two step, two epoch, already you go up here, and you will not get the global cost minimum. Okay, so for the deep learning, they are used in many applications: image recognition, computer vision, text classification, multi-class classification, regression problem, and many more. So I noticed that um, many of you are doing research in trying to use machine learning, trying to learn a few data that you have. Okay? The advantages of using neural network, one of them that they can be used both for regression and classification. Okay, so you can do regression, you can also solve the classification problem. And neural network are good to model with non-linear data. So if you have non-linear data, so it best to use neural network. Okay. Um, Once trained, you can perform the prediction very fast, and neural network can be trained with any number of input. So no matter how many parameter you have or how many variable you have, you can still use neural network to train them. But you need more sample. So neural network work best with more data points. So in return, you also have disadvantages. When you have less number of sample, neural network cannot work the best, which is this one. Okay, and the other disadvantages of neural network is that they are black box, in which you cannot explain what happened inside, why certain sample is considered positive or negative. So there are no guideline. They just give you positive or negative. And then for the deep learning, if you do not have GPU, it will burn your um, processor because it will take longer time. Um, very expensive and time consuming. Okay. So best practice is neural network are best implemented when there is a good training data. So that's why when you want to do your project, finally a project, it's good to have what kind of data that you want to process. You have to know what to process, what type of task that you are doing, regression or classification or clustering and many more. Okay. And another issue that you need to deal with is how many hidden layer that you need. 5, 3, 10. So what is the best number of hidden layer? So it all depends on your data set. Okay, so each data set will have different characteristic. So you may have to try a few number of hidden layer, and also in each hidden layer also you have to determine what is the best number of um, neuron. And it is say that the best is 5 nodes, 5 neurons in the hidden layer. So you can rectify this one in your experiment. You want to try 3, 5, 10, and so on. Okay. And also when you want to decide what activation function, um, ReLU has been proven to be more effective in finding the best solution. So maybe you can try ReLU, and also you could use a sum of square error. This is used to measure for regression or for numerical value that you try to learn. Okay. Any question? Can you type number 3 if you're still with me? Okay. Can you type number 7? Number 7. Oh, 13 orang saja nih. Okay, can you type number 10? So I want to have more than 13. Okay. So let's take a look at how do we perform the neural network algorithm in trying to learn our data. Okay. We will use the R neural network. So in trying to learn this type of data, so if you look at this data, we have input, we have the output. Okay. So how do we teach? How do we train neural network in such a way that given any input, it will give you this output? If you type 3, they will give you 9 and so on. Okay. So the first thing that you need to do is in R, we have a few packages of neural network, and one of them is called neural net. So we will install this one, and then we will use this library. Okay. So the data that we are using will be stored in the square CSV, and then we read our data using the read.csv. And then if we want to look at the data, we just type my data here. So this is the input and output. Okay. And when we perform this command attach my data, basically we are trying to attach the data that we have in my data to the R search path, so that we can access them easily. Okay. So if you want to look at the name of the variable, we just type names and then my data, and we have input and output. Okay. So what we want to do is we want to model this input, and then we want to estimate the y, and also this is our output plus the bias. Okay. So to train the model, so basically we call this function called neural net, and then the formula will be the output will be your y, and then tilde, and then x. Okay. So the data that we are getting from my data here, and the hidden layer will be 10, and the threshold is this one. So this is the threshold value that we are looking at. Okay. So if we print the model, so this is how it looks like. We have one input, and then we try to map to the output. Okay. And we have 10 nodes here. Okay. So this is the weight given. This is the bias. Okay. So so this is the model that we train. So how do we actually compare with the actual one? Because we are talking about this output kan. So our output will looks like something like this. So this is our output. This is our um, the actual output for this input. Okay. So if you look at this one, so basically we are trying to we get the input, and then we get the output, and then we get the result from our model, and then this is the result that we get from here. This is just renaming the column. Okay, so 3 column, and this is what we get. Okay. Okay. Um, okay. Before I summarize this one, let me go through another one. Let me go through this one so that you can look at how we perform that one in R. Okay, can you see my screen here? Okay, boleh nampak? Boleh ya? So this is the R software, so you need to download lah. Okay, hopefully you have tried to install them and then try to do practical number one. Okay, so if you have installed them, for example, So we need to install first. So they will ask you for the mirror or the crane. So just click OK. Use the default mirror. So basically this will install the neural net package, and then we will upload them into memory, which means that we will be using them. Okay. And then we will read the data from our directory. Remember that you always make sure that you're reading from the right directory. So I'm going to my article number 3. Okay, so if I want to look at my data, I just have my data. So this is my input and my output. So if you want to look at the name of your column, okay, okay, we have to attach this my data to the R path so that we can use them later on. Okay, so if we look at this one, so we are using the neural net, and this is the formula, and this is the data, and this is the hidden layer. So the model that we have will be plot model. So this is our model. Okay. So if you want to look at the okay, for the first statement here, basically we are trying to combine the column here and put in the final output. So the input will come from the input, output, and also the results that I get from the model. And then I just rename the column name, and then I print out the output. Okay. Um, okay. Any question? No question.